format. I'm sure they've showed you some of the basics of how to convert from binary to decimal. But I doubt if they showed you guys this format. So I want us to go through this format because this is actually the easiest format to convert binaries to decimal, especially when you're dealing with 8-bit system architectures. So every computer system, for the most part, uses 8-bit computer architecture system. It's a processor that might change in its architecture, which is like, for instance, you have a 32-bit operating processor and a 64-bit processor. These days, they've been going higher than 64 bits now. Supercomputers are running at 128 and then 512 architecture. But for the average computer system, for your laptops, desktops, or whatever that you use at homes or in your offices, they're either going to be, today, it's purely going to be 64-bit. At a point in time, it was 32-bit, and then they realized 32-bit architecture wasn't, in terms of memory, wasn't enough. So they switched to 64-bit ones, and today it cuts across. Just about any computer you buy today would come with a 64-bit processor core setting or architecture. And it's designed to basically allow for a lot more room for the arithmetic logic unit, or the ALU on the computer board or computer component to be able to process information much faster. So generally, when a computer is much faster, it's probably because you have a higher architecture, or you have a higher amount of memory allocated to it. Okay, and that's one of the reasons why when you guys go out to buy machines or a laptop, you say, I want an Intel i-Core i5 or i7 or i8 or i9 today, because the higher the core means you have a lot more processor that has got a higher 64-bit standard or architecture built on it to allow you to process information a lot more faster. So the more cores, the higher your processing speed. Okay? So anyways, for most 8-bit computer systems, which cuts across, here we're talking about how the informations are actually categorized in terms of the binary operations, in terms of information exchange or the signal exchange. They are mostly in 8-bit sequence. So if you're dealing with any computer system, that will always have 8-bit sequence in processing data, then this is the best way to actually handle binary to decimal conversion. I'm going to go through it with you guys. This is very, very essential to IP addresses, because you're going to have to understand this to be able to understand how you're going to be able to manipulate the IP addresses to give you certain allocations for a given network that you want to set up or that you want to operate within. So we always start out with the conversion, so at least you guys understand the basics of conversion between binary and decimal. And once you got that, then you start knowing how to manipulate them, how to add them to get you using the logical operands like XOR, and what else you have? So you have your AND, your XORs, and then your ORs, right? For most of you that did architecture. So anyways, so if you have 8-bit systems for data exchange, the concept here is that since they are represented in binary format, it can only be 0 or 1. Engineers came up with, all mathematicians or scientists behind the implementation came up with this concept that if you have 8 bits, so I have 8, 1, 2, 3, 4, 5, 6, 7, 8. And then in binary format, so it can only take 2 states. It can only have 2 states, which means that it can only be on or off. Whenever they are off, their decimal value is always going to be 0. So if it's all zeros, it means they are in an off state. Their total decimal representation for the 8-bit is a decimal of 0. But the very moment you switch on any of these 8 bits into a 1, then it take on a log of base 2 value. So this is where we have your log base 2s. So the first rightmost bit has a log base 2 value of 2 raised to the power 0. Now they're using log because it's in binary. It's either 1 or 0. Sorry, 0 or 1. So it's 2 states. That's hence the log base 2. So the first rightmost bit has got a decimal value representation of 2 raised to the power 0. And 2 raised to the power 0, let me see if I can erase this one. All right. For the time being. So at least I can put the representations over there. Actually, I didn't need to do that. Let me just go back and forth. Okay, so 2 raised to the power, whenever you change any of this bit sequence to an on state, they take on the decimal value of that log characteristics or element that it has. So 2 raised to the power 0, if this were to be a 1, would give you a value of 1. So this will actually be a 1, a decimal of 1. Keep that in mind. If it goes to 2 raised to the power 1, it becomes 2 decimal. If it goes to 2 raised to the power 2, it has a decimal of 4. 2 raised to the power 3 is 8. 2 raised to the power 4, 16. So if this bit is to 1, you have 16. 2 raised to the power 5, you have 32. 2 raised to the power 6 is what? 64. 2 raised to the power 7 is 128. Now, if you were to add up all of this decimal value, you get a decimal value of 255. So it means that if you were to switch all the zeros on, the maximum decimal value you can get is 255, which is the maximum number of allocation that any character can take on within an 8-bit registry within a computer system. So 8-bit sequence maximum is 255. And you start noticing this a lot when you start programming. You will notice that if you declare a variable type, the maximum characters you can fit into it will be 225, especially if it's a varchar. It would have a total value of 255. You cannot exceed that because of the fact that every computer system uses 8 bits architecture for data interpretation. If you want to increase a 255, then you have to switch the type to either a text or something else. Text can have unlimited number of allocation that it can take. But if it comes to basic interpretation of each of the characters that a computer system can use to represent any character that it has to use for any information exchanger, then it can only have 8-bit sequence. So all the characters you see on your computer boards, on your keypads, the maximum value that it can take on this decimal is 255. They can't go beyond that. Otherwise, the computer system will not accept their characteristics. So keep that in mind. Every character in registry within an 8-bit sequence computer system registry would have 8 bits to work with, which has got a decimal value of 255. Okay, so given that, you only have those values in case you were to switch any of the 8 bits on or off. So with that said, let's try to manipulate some of these zeros and ones. Sorry, zeros, so we can get different values. Okay, so let's take, for instance, I have a binary of 0, 0, 1, 0, 0, 1, 1, 1. What will be the decimal value for it? So you have to look at the bits that were switched on. We switched on this bit. It's on. This one is on. This one is on. See, they're all 1 on 1. But these guys is off. It's off because it's 0, 0. And then we switch on the 1 2 raised to the power 5th. It's switched on. And then the rest, 2 raised to the power 6 and 2 raised to the power 7, are still in off state. So which means that we can only add up the on values to get our decimal. So it means that this binary here, if you were to convert it to decimal, it will be 32 plus 4 plus 2 plus 1, which is what? Anybody? So this is 5 here. No, this is 7 here. 7 plus 32 is what? 39. So we have 39 decimal. Another one. 0, 0, 1, 1, 1, 0, 0, 0. Now we only switched on 2 raised to the power 8. So it means this value is 8 over here. We also switched on 2 raised to the power 4, which is 16. And we also switched on 2 raised to the power 5, which is 32. So it means that the rest are all zeros. So it means that the decimal is 32 plus 16, which is 48. 48 plus 8 is 56. That's a 56 decimal that we got. I hope you guys are paying attention to this. Okay. Now I'm going to let you guys solve this one. What if you have 0, 0, 0, 0, 1, 1, 1, 1. What will be the decimal? Guys, unmute your mic so you can talk to me. But at least I know you guys are Talk to me, guys. So what will be the decimal value for this one here? Hello?
Say we are here.
Yeah, give me the answer. Don't tell me you're here. I know you're here. What's the answer to that question? What is the decimal value for this binary? 000011111. What would it be?
Say we are calculating it.
All right. Shouldn't take just that much time. It means you have 8 here, you have 4 here, you have 2 here, and you have 1 here. So it's 15. What is 8 plus 4? 12. 12 plus 2, 14. 14 plus 1, 15.
15.
Who said 12? Master, can't you count? Okay. So it's 15. Okay. Now what if you have 1, 1, 1, 1, 0, 0, 0, 0. What is the decimal? Anybody? Hello? What would that be, guys? So if you guys are not going to talk, I'm going to spoon feed you. Since you guys are just so sitting back over there watching, there are only 8 participants. So you have 128, 64, 32, and 16. The rest are all zeros. That will give you 240. Because you have 128 plus 9 from plus 64, which is 192. 192 plus 32. Anybody know what that is? Anybody? Hello? Anybody, guys?
256.
224. Come on now. It's 196 plus 32.
Okay, yeah.
It's 224. 224 plus 16 is 240.
Yeah.
Very good. This was a 15. This was 56. This was 39. So this is 240. Yes, 240. Now, usually there's a simple way to guess this one. Since, now you pay attention to this one, it's a trick. Since the total decimal value that you can get when all the bits are switched on is 255. And you know that the first 4 gives you 15, then you can easily take 255 minus 15, which will give you 240. Does that make sense?
Yes, sir.
So the same thing with this guy, with this one over here. Since you know that the maximum you can get is 255, and you know 240 has been switched off, it means that you have so like with this one over here, another way to get this one is to use this. Since you know that the maximum you can get is 255, and now you have switched off 240 of them, and you know that the first 4 is going to give you 15. Because these are the only 4 that has been switched on. In this case, which out of 15. In this one, the beginning or the last 4 have been switched on, so they give you the 240. So you always keep it in mind. The last 4 on your left, if they are switched on, the last 4 bits on your left, if they are switched on, they give you 240. And if the first 4 on your right are switched on, they give you 15. So 15, so you can even put them together. So if you have all of them being 1, 1, 1, 1, 1, 1, 1, 1, it just means that you have 240 plus 15, which gives you 255. Because now you have all the bits switched on. The first 4 here, the first 4 here is 240, or the last 4, and the first 4 here is 15. So if you add them together, you get 255. Am I making sense now, guys? Hello?
Yes, sir. Yes, sir.
Okay, great. So now I hope you guys can do the manipulation easily, right?
Yeah, yeah.
Okay, so
Yes, sir.
let's do some examples then, and then you guys give me the answers. So what do you have when you have 1, 1, 0, 0, 0, 0, 0, 0? What's the decimal?
I'm coming.
Anybody?
It's 63.
Oh, Masa. Where did you get 63 from?
Hey. So the one you add the 128 plus 64, then you subtract from the 255.
Oh, this bit and this has been switched on. This one carries 128. Now 64. So it's actually 192. These are the 2 that are switched on over here, and they have these values. It's 1100000. That means you still don't understand this whole concept.
So
Yeah.
aren't you going to add the 128 plus the 64?
That's what I did, and I got the 192. 128 plus 64, what is that? It's 192.
192. Okay. So when I had a 192, then I subtracted this from the 255. Sorry.
No. You only apply those concepts when you have it in this format, in all ones here or all ones here.
Okay.
That's where you apply those shortcuts. But when you have it in this format, you don't want to do that. No, don't do that at all.
Okay. So give another example.
Okay. Another example, you have 1, 1, 1, 0, 0, 0, 0, 0.
224.
Huh?
224.
Correct, because it's 128 plus 64 plus 32. Okay, you guys are catching on now. That's good. Okay, so now what is this way now? Now let's go this way. 1, 0, 1, 0, 1, 0, 1, 0. What is that?
Say who? One 165.
165. Is that correct? So you have 128 plus 32 plus 8
8.
plus 2, right?
The 166. Yeah.
Is that correct?
Yeah, 166 is correct.
166. You guys are getting the concept, right? It's a pretty straightforward concept. All right. So in this case, now let's introduce an IP address. Since you understand this concept here very well, let's start introducing IP addresses. So here's an IP address. So on my computer here, we had, I had 192.168.1.170. So I have 192.168.1.170. Now convert all of this to binary. So now they're in decimal. So now you're going backwards. So to accomplish that, you have to take 192 first and then convert it to binary. So what would 192? It'd be what? 1100000. 168. What would that be? Anybody? You can go back and look at it and reference it. 128 plus 64 is 192. So you can't flip the second bit on. So it has to be, first bit has to be 1, second has to be 0, it has to be off. But 128 plus 32 is 140. Sorry, 160, right? So that's about right. So we can flip the 32 on. And then we need 8 more. So it means the 8 bit has to be on now. Just the 8 bits, and the rest has to be zeros. 1 is just 000000001. And then 170 is what? Since we knew this was like this, we have to just flip 2 more on. We have to flip the 2 on. So it becomes 101.01010. So I've just converted this IP address into its binary format. So in representation, this is what it will be like if we were to represent it in binary, of the binary of 32 bits. So you're going to have 11000000 dot 101.01000 dot 0000001 dot the last one 170, which is 10.